If you guys have any questions throughout this presentation, feel free to just type them in the chat, or if you want to unmute yourself and ask, go ahead. Feel free to interrupt at any point or ask me to slow down if I speak over something that just needs a little bit more explanation. I'd be more than happy to give you guys a little bit of a deeper insight. So, anyway, my name is James Arce. I'm the Systems and IoT Business Development Manager. I joined Samsung about 2 years ago, and prior to that, I had a lot of experience working with process engineers as a DCS integrator. And I'm here to present to you guys SamGuard, predictive analytics solution for the process industry. So, what SamGuard is it's human enhanced machine learning, and it's at the forefront of the digital transformation. How it came to be is we used Samsung's 113 years of experience in serving the process industry and combined it with the innovation that we acquired from Precognize about 3 years ago. So SamGuard works in the process industry, specifically from chemicals to petrochemicals, pharmaceuticals, mining, oil and gas, etc. We believe that this is really the best place for something like SamGuard because of all the different variables in the process industry, things changing constantly, multiple times per second. We have customers from all over the world, from Asia to Europe, South America, and North America, of course. I think we have over 50 customers, a lot of them with multiple installations. So some of our customers have, 4 or 5 or more plants. We partner with a lot of the historian providers as well. So a lot of the very common ones, Siemens, OZSoft, so Pi, etc. So that's just a little bit of background about SamGuard. So what is predictive analytics actually? Well, when this all started, one of the biggest buzzwords was, predictive maintenance. And what that basically means is, the wish for company to extend the life of a singular component. Well, while there is some money to be saved in making sure that your parts, fail less often, what we realized was the value of additional production far outweighs the value of maintenance savings that you get by preventing the uh, breakdown of singular components. So that's where SamGuard focuses on. We focus on more production. We focus on making sure that you have 100% availability as much as possible. So how can we do that? How can we help you increase production? Well, the way we see it, there's two types of problems in the process industry. You have your repeated and known problems, such as optimization. So, for example, you're trying to solve some quality problems, or you are trying to repeat a golden batch and optimize your process. These problems, you know how to go about solving them. And then there are the unforeseen events, basically known problems with unknown causes. So think about this as a valve that suddenly fails catastrophically. You didn't see it coming. You didn't expect that to happen, but for some reason, it just seemed to have failed for no apparent cause. Or maybe a compressor that all of a sudden just shuts down without any prior warning, at least in our eyes. So this is the area that SamGuard works in, the unforeseen events. Well, some of you may be wondering, is there even any money to be gained by preventing these unforeseen events? Well, in order to get a little bit of background on that, we asked one of our petrochemical customers, hey, can you give us a monetary value of how much money we saved you because of preventing these unforeseen events? Now, of course, since the problems were prevented by SamGuard, we actually, don't have a clear dollar amount. So what we asked this customer to do was, hey, can you give us an estimate? Can you give us a low end and a high end of the amount of damage that we could have prevented if the problem wasn't identified? What we found was in a 2 month period, this customer saved somewhere between 140,000 to $4 million. And that's not including the $14.5 million of total risk exposure. So what I mean by that is, let's say that, a valve fails catastrophically and It sends metal shards down the line, and now a fluid tank or something has been punctured, and it causes the entire plant to shut down. That's the total risk exposure. So as you can see, the return on investment and the value of preventing these unforeseen non-repeating problems is huge. So how can we do that? How can we prevent these unforeseen problems if you don't know where in your plant they're going to come from next? Well, we do that by covering the entire plant, right? We like to call that an orchestration of 1,000 parts. The reason we do that is, as we just said, you don't know where your next problem is going to come from. Even though Samson is known for our valves, we look at everything from your reactors, compressors, valves, tanks, distillation columns, heat exchangers, everything. The reason for this is because the parts that failed in the past probably won't fail in the future. And even if they do, they won't fail in the exact same way. With SamGuard, we cover everything. So just to give you a little bit of an example of that, we have this case study here of a Joy compressor. We gave the alert about 40 hours before failure, and unfortunately, it still failed because when we gave the alert, it was a Friday evening. We sent it straight to the process engineer, and the process engineer had already gone home for the weekend, so he didn't actually look at the alert. So the compressor failed. We do something different now to make sure that there's always somebody to get these alerts and to make sure that something like this won't happen again. But anyway, if you were to ask a compressor expert, hey, what are some things that I need to look at in order to maintain the health of my compressor? Well, they'd probably say, oh, you need to check the vibration, you need to check the power output, downstream pressure, etc. They would never say you need to look at the differential air pressure to the filter before the compressor and the temperature, right? In reality, these two variables are the only indicators we had that this compressor was going to fail. And we gave the alert again about 40 hours before failure, and that's about the time frame where you can expect SamGuard to give an alert to 24 hours, a few days, maybe a week or so in advance. Do you guys have any questions so far? All right, I'm going to go ahead and assume that that's a no, and I will move on. So how can we do that? How can we prevent these problems? Well, the best part is the data is already there. So SamGuard doesn't actually need any additional hardware. We don't need to put vibration monitors, steam trap monitors, nothing, right? You already have your DCS that's logging data points in your data historian, thousands, hundreds of thousands of times per day, right? What we do is we have SamGuard on site, so there's no IT issues, and SamGuard takes that and turns it into a machine learning model. And basically now SamGuard is monitoring your plant 24/7 non-stop. SamGuard doesn't take any breaks, doesn't have to go to the restroom, doesn't go on lunch, no vacations, nothing. SamGuard is always watching every single part of your plant. So let's give you guys a little bit of background on that machine learning that I just mentioned. So we've already established that you have plenty of data and your problem can occur anywhere. The issue, though, that's unique to the process industry is the fact that you have very few identical historical problems, right? So to give you a little bit of statistics background, you'd need something to fail identically about 30 times before you can go ahead and use it as a statistical model, right? So that being said, supervised machine learning just won't work. We don't have enough identical historical problems. So what do we try instead? Well, why don't we try unsupervised machine learning? So what we would do is we use your historical data, we upload it to the machine learning algorithm, and the machine learning algorithm through an unsupervised process creates these normality clusters. Now, each plant may have multiple normality clusters, but for the sake of this example, let's say this is the normality cluster for summer, and this one is the one for winter, right? Which means that as long as, during winter time, your tag one is between these values, you're good to go. That means your plant is running completely normally. And the reason we do this and the reason we take about 13 months actually of historical data is we assume that in those past 13 months, for a majority of the time, your plant was running just fine, right? So now we can say, okay, tag 2, anywhere within these values during winter time, completely fine. Tag 3, tag 4, tag n, and so on, right? And then we save that as the baseline machine learning model. Now, this is usually the area where most of our competitors stop. This is the end of the line for them. The issue, though, when you do just that, is you have a lot of noise, right? And think about that. We'd have a lot of noise because of you have thousands of tags. If even 1% of 10,000 tags is an anomaly, you'd still have over 100 alerts per day. So what can you do? Well, maybe you can take a few assets and clean them. Again, this is where some of our competitors stay. Maybe they'll just watch the compressor or maybe just the heat exchanger. Basically, they're mission critical components. Now, again, the issue there is we just said that the root cause of some of your issues could come from anywhere in the plant. So if you're only watching the compressor, well, something might cause the compressor to fail way upstream that you wouldn't see if you weren't looking at everything, right? So the issue there is it's not scalable. So what do we do with SamGuard? Well, we add context to the entire plant. And the way we add context is, fortunately, it's in a way that most of you guys already have. A lot of our customers have P&IDs. Unfortunately, the machine learning cannot see this P&ID. It's either on a PDF or on a paper. The machine learning can't use it. So what we need to do is we need to model it with SamGuard Studio. Now, modeling with SamGuard Studio is a relatively easy process. It's really, really quick. I'm going to try to talk through it as this video is blazing through. But basically, we just model the plant structure, the plant behavior. It's a very clear and intuitive process. And the best part about this is it doesn't need to just strictly adhere to your P&ID. If there's any expertise that the plant operators and the plant engineers can provide to us, we can easily add that into the modeling process as well. So what we do after we model the data headers, the plant structure, and the plant behavior. So what I mean by plant behavior is, let's say this control valve influences this level meter, and then this level meter influences this fan, etc. Basically, we want to know how these components interact with each other. Once that's done, it is now in a form that SamGuard can understand. We convert it into a causality graph, right? That way, whenever those anomalies show up here, here, or here, just as an isolated anomaly, SamGuard knows not to give you an alert. However, once we start to see a chain reaction of anomalies around the same area, then we know where to tell you your next problem is going to be. And we know exactly uh, where it's going to or why it's going to be in that spot. So just as a quick background, here's what we do. We take your historical data and we create a baseline machine learning model. We take your live data and we run it through the machine learning algorithm or the baseline machine learning model. Now you have all of these anomalies that are showing up everywhere. However, because SamGuard added context to it, we can tell you through a guided analysis process exactly where your next problem is going to be. And again, we don't cause alert fatigue. In fact, for a plant of about 10,000 historian tags, we provide an average of 5 alerts or less per day. Do you guys have any questions so far? Feel free to type it in or unmute yourselves if you guys have any questions. Nope. All right. So here's a quick example of a case study where, you could really see here that there's a lot of spots on this graph where the data oscillates quite a bit. If you had any higher or low level alarms here, they might have gone off, right? If it didn't go off here, it definitely went off here. And as you can see, this time frame is months apart. So this is March right here. This is April. This is May. This isn't just happening in a very short span. SameGuard didn't give an alert here, didn't give an alert here, not even here. But we did give an alert here. Now, none of us are experts in methane production, but as soon as we showed this alert to the operating room or to the control room, to the operators, they immediately knew that this was a leak in a methane tank. These two tags are actually gas detectors in the interstitial space on a methane tank. So that's just a really good example of how we don't provide any alert fatigue. We don't provide, a whole lot of false alarms. We don't let you know, or we don't ping just random anomalies. We give you guys actionable alerts. So this goes back to kind of what I was mentioning as far as that alert that went to that process engineer. There's multiple different implementations of options. The best thing that we found we could do is send these alerts directly to the control room. Reason for that is because there's always somebody in the control room 24/7, and they are an excellent first line of review. Those guys are experienced, they know what they're looking at, and they're always there to react to an alert. Now, the second line of review would be the process engineer. So we would give this person access to SAMGuard as well. Basically, let's say the operator sees something that they don't quite understand, they can send it and forward it over to the process engineer and ask for more clarification. Another option we have is the Plant Analytical Monitoring Center. Now, this is similar to a control room. However, it's kind of like a control room that handles a lot of different plants. So let's say you have a location with, you know 10 different units, and it's just way too much for SAMGuard to be in 10 different locations. We can do a plant analytical monitoring center local to all those plants. Alternatively, we can also do a corporate analytical monitoring center. A lot of our customers actually like this option because, let's say, let me just use our cement customer as an example. That process is pretty much going to be similar no matter where you do it in the world. Of course, some variations due to humidity or water content might change things, but generally you have the same process. You can monitor it from your corporate location, and we can do this as well. We can make it so that SamGuard sends all its alerts to the corporate center. Our last option is the remote analytical monitoring center, and we actually offer this service to our customers as well. So this is, we do have process engineers as well. They are experts in the field, and what we can do is we can have the alerts get sent straight to them. They can review them and send you the ones that they believe really needs to be acted on. So this is an excellent option for somebody that doesn't want to hire additional data scientists or just doesn't want to hire somebody to look at this 24/7. We can also offer that service as well. So what does this really need for IT preparation? Well, this is actually a very, very quick process. As it relates to our competition, because it only takes about 2 weeks to implement SamGuard at a new site. And as I've mentioned before, it does not require any hardware installation. All you really need is a 16 gig CPU, 128 RAM, and 1 TB of memory on a Linux virtual machine. We've actually found that a lot of our customers just have this laying around. I believe these requirements have been reduced even further. So again, it really doesn't require a whole lot. But once IT preparation is done and you have about 13 to 15 months of extractable data, then we are ready to go. And then we come to the setup stage. Now, the setup stage is an important and significant part because this is basically where we are translating the PNIDs and as well as your process engineer's knowledge to the software. So we say, start where it hurts the most. So start in the unit where you have the most problems, right? What we say is it takes a process engineer about 2 weeks, so they can do about 300 tags per day. So, if you have about 2,000 to 3,000 tags, that'll take about 2 weeks. Following that, You go to another area of your plant. And again, there's two options for this. So what you can actually do is you can collaborate with us and our process engineers. Now, this is going to be good and bad because as you see with our other option, it really depends on how much time your process engineer has available. You can either collaborate with us or you can do it by yourself, or you can do it with our expert. The downside for using our expert is not all of the knowledge that the process engineer has can be incorporated onto the software. Of course, we'll be consulting every time we don't understand anything, but it just won't be as efficient as if you guys did it yourselves. However, these options are not mutually exclusive of each other. So, for example, let's say the first time you'd like for us to do it with you with our expert just so you can learn what exactly we're looking for, what type of things we need to include and what type of things do we not need to include. And then as you expand it to your second unit or second plant, you can go ahead and do it on your own. Either or, at the end of the day, your entire plant is modeled and SamGuard is up and running. So now we are in the online phase, and what we've discovered is our biggest successes have come from customers that have really invested, management sponsorship into SamGuard. This is a paradigm change. You are going from reactive to predictive, and we do need the management on our side. Again, the projects we were most successful was where the management was very, very involved. We even had some places where the CEO was specifically asking, "Hey, is SamGuard working right? Do you guys get alerts that make sense? Are you guys using this software, this and that?" Um, but yeah, management sponsorship is key to make this project successful. And the best part about this is, we're here to help you. This setup and IT preparation and in running online. This isn't okay, here you go, we're set up, we're out of here, you're on your own. No, we will help you. Every time you get an alert you don't understand, or every time you have any questions, we are available for you in order to assist you and make sure you understand and make sure that you guys are running as smoothly as possible. So, just as a quick summary, we cover the entire plant. We don't just cover a specific part of a specific piece of equipment because, as I've said, you don't know where your next problem is going to come from, so your entire plant needs to be covered. We don't provide alert fatigue. We have 5 alerts or less per day for 10,000 tags. We detect your unexpected issues, your equipment failures, process deviations, blockages, etc. And we don't need a data scientist. You can actually analyze the alerts using your own operation staff if you so choose. And 1 to 2 week implementation with no hardware required. So, as you can see, it's very simple, and it's relatively intuitive and easy to use, and it can really add value to your process plant. Anyway, thank you guys for listening to my short presentation. Do you guys have any questions?